Hello and welcome to No CPP Diagnostic Chat Required, a convergent look at what's going on in the world of C++, rounding up the news and chatting with guests from the community. But before we find out what's really going on and who the hosts are, John is here with a disclaimer. John.
Thank you, Phil. This website does not provide medical advice. The information, including but not limited to text, graphics, and images and other material contained on this website, are for informational purposes only. No material on this site is intended to be a substitute for professional medical advice, diagnosis, or treatment. Always seek the advice of a physician or other qualified healthcare provider with any questions you may have regarding a medical condition or treatment, and before undertaking a new healthcare regime, and never disregard professional medical advice or delay in seeking it because of something you've read on this website.
Well, if my intro didn't confuse you, then I'm sure that disclaimer did. So what is going on here? Well, as many of you may know, I actually co-host two podcasts, although one of them hasn't been running just recently. So we have No Diagnostic Required, co-hosted by Anastasia Kozakova here, and CppChat, which we last did an episode of, I think, back in April, co-hosted by John Kalpier. So what we're doing this time is each of you are guests on the other show, and we're going to run them simultaneously. So this is probably going to be a one-off.
Welcome, Anastasia.
So the way we do it with No Diagnostic Required is it's all focused on the news, a bit of standards news, a bit of general community news, and then we have a bit of discussion. The way we do it on CppChat is it's a case of the guest tries to stop John from talking too much. So we're going to do a bit of a mix-up of those two things today. So we've got some news to get through. So we're going to start with the community news. Anastasia, I think you've got a blog post you want to tell us about.
Yeah, I'm actually going to start talking about the code analyzers and code analysis. I think that's the topic quite close to you, Phil. But yeah, I would be happy to listen to what John thinks about it as well. So this is actually an article from the PVS Studio blog. And if you're not yet convinced that static analysis might be helpful for you, and you might need some more real-world examples to prove the third, just go to this article and read through it, because it actually starts with a few very interesting examples from the open source projects, like including the LLVM and some others. So there are some basic errors there probably, but they might hurt badly in some unlucky conditions. So just go through it to prove for yourself that you actually need a code analysis. And when you believe in that, you can explore the options. So static analysis actually just one of the options to be taken to prevent such errors. So you might take the testing, the code reviews, the techniques like sanitizers, whatever. But the article is focused around a very specific thing, the static code analysis, mostly because the PVS Studio actually is doing a code analyzer. So probably that's the reason. Yeah, but actually they're talking not just specifically about their tool, but about various errors, but also about the checks their analyzer can perform. And I actually like the last part of the article when they discuss various static code analyzers and how actually to choose from the existing variation, because we have many of them, luckily, in the C++ community, and that's the situation when we have more tools, and that's a good situation compared to, project models where that's a nightmare that we have that many of them. With static analysis, I think that's a good thing to have lots of them. So, they discussed the topic of the false positives and the analysis baseline. Like maybe that's an important thing to have, just not to be, blown up with lots of warnings. And that's actually interesting to me because recently I was exploring this idea of, gamification in code analysis, when you might move through the code analysis in your project, like level to level, getting some, achieving new levels, making some team achievements, whatever. So when you not just, have all these checks jumping on you when you just open the code base, but you go for this using some, kind of a game analogy when you have some baseline and then you move forward. So I kind of like this discussion. But I may be more interested of what you, Phil, think personally about the article, because I guess you just recently written an article about the Sonar Lean, and we were discussing it in the previous episodes. So have you found it interesting reading for the PVS Studio article?
Their articles are always interesting. I do have to be careful what I say because from a business sense, we are technically competitors. Those of you who have been around the C++ community for a while will know that all of us as competitors are actually friends. So that's fine. But yeah, I do need to be careful what I say. One thing that did stick out to me in the article was the point about using multiple analyzers. So, why not use PVCS Studio and SonarLint? You'd never do that with something like a compiler or a debugger, running both at the same time. But with static analysis, it makes perfect sense because we all concentrate on different sets of warnings or rules. And if you use more than one tool, you'll get even more results. So I should probably stop with that, I think, and see what maybe John thinks.
Well, actually, this is one thing that in my career, I always wished I was in a situation where I could use multiple compilers, not because we were going to ship multiple bills or something like that, but because I wanted to get the different compilers have different hints they give you, or I should say different warnings they give you about what may be. And that was one of the nice things when I worked on truly portable code is that you would the code you were writing that was going to be run on another platform was going to be looked at by a completely different compiler, which would have a completely different set of warnings. And sometimes we would get better information for that reason. And I think that multiple static analyzers is going to do the same kinds of things. The different analyzers, of course, are going to have different checks, and that's going to give you better feedback. The challenge about the static analyzers is really how you can get it to fit into your workflow, because the information is so valuable. It's kind of like, imagine you could hire another programmer and all they ever did was stare at your code and tell you if you'd done something wrong. Of course, it's not a human, but that's got both pluses and minuses. Obviously, it doesn't think the way a human does, but on the other hand, computers often do things that some of the things that computers do are much better than what we as humans do, and some things are really awful. And so that's what we're getting, is what the computer can do really well for you. Don't overlook that. Find out how you can make that part of your workflow, and get the benefit of that. I've always wanted to have the computer tell me more about what it didn't like about my code. Not that I always listened, but I wanted to hear it.
Yeah, it's a good point about listening to the things. Actually, I think when you have these kind of tools integrated in, for example, your IDE, there's a very nice approach that we tend to use in JetBrains is when we're not sure that if the warning is going to be like too annoying maybe for the user, we just convert it to a thing called intention, that it's not jumping on you with a warning, but you can like press Alt-Enter and see the suggestion to change the code. And that kind of, a little bit removes the level of stress when you have all these warnings jumping on you from the analyzer if you haven't configured it properly for your code. So that helps a little bit. Sometimes it's hard to then find the thing there, but if you know about it, it's like a little bit helpful. But yeah, overall, I agree.
But that's why you want to spend some time and invest with it, because you can silence those things. You can say, I've investigated this. I don't want to hear about this anymore. But particularly with new code, I've written these 3 new functions, and I need I don't need maybe, but I would like the computer's opinion or the software's opinion of what I could do to make this clearer. And sometimes, I do think about the code, and it's like, no, I'm pretty confident this is correct, but maybe it could be made clearer, not just to satisfy the analyzer. I don't care about that. But if it was too hard for the analyzer to figure out, maybe it's also too hard for a human to figure out. So think about, and that's the reasoning through the process and convincing yourself, no, this is really the correct code. But at that point, you really understand it better than you did when you wrote it. And so that's when the time to say, maybe I could write this in a way that's even easier to understand. Because to me, my top priority has always been about clarity. Of course, I want it to run fast, and of course, it has to be accurate. But if it's clear, then it's easier to maintain. It's easier for me to come back. and pick it up, understand it, maintain it, fix it if it's not accurate, all those kinds of things. So I'm really striving for clarity. So if I can understand the code better, and as he said, looking at the analyzer and saying, why does the analyzer think this is wrong? What's wrong? And then you begin to get it, and you say, oh yeah, that's that could be a problem. I'm pretty sure it's not here. Maybe I can make this clearer so that it's obvious that that's not a problem. And I think that's a win.
Yeah, I kind of agree. And maybe talking about the clarity, that's a good move to our next topic. So let's discuss a little bit more about the readability of the code and clarity of the code. That's another article which actually addresses a very typical issue, typical problem in the code. And it's the case when you have two parameters of the same type. Specifically in the article is just the booleans in the example, and they're passed to the function or as a template parameter. And you can just, change the order and make a mistake. That's a very typical thing you can do. And I guess we all do write this code at least once or twice, or maybe many, many times in your life. We all by accident sometimes are passing the arguments in the wrong order. That happens. And that's breaking the code. And the article talks about several approaches on how to avoid the issue. And it's specifically focusing on first of all, how to express the meaning of the parameters in the code itself. So the readability aspect. And the second is actually, of course, the preventing the wrong usage in compile time. So not just noticing it too late, but noticing and capturing it in compile time. So the list of suggestions starts from some very naive thing adding commands to the code, which is a good suggestion, but how many of us are actually doing that, especially for that reason? Type aliases is also good, but finally the strong types are definitely the best solution from the article. And what I actually liked about it when I was reading through the article, the strong types, using the strong types is the advice I usually hear when I talk to people about the type hints we do in the editor. We add in some hints to the parameters and to the types so that the user can actually see what they have there. And the users quite often say to me that, the hints are good, but we'd probably better use something like strong types to avoid this code and to avoid the problem. So it's good that the people are actually started thinking about this kind of thing. So I kind of think that's a nice article, just not a very, it's kind of a basic one. An example is very basic, but it explains just the approach in a good way. So what do you actually both think about it?
The one that always gets me is the constructor for stood string that takes a character and a length to repeat that character for. I get it wrong every single time. And I don't even notice straight away because it compiles and sometimes even prints what I expected.
And then something weird happens. Yeah.
Yeah. So this always...
Yeah. No, go ahead.
Go ahead. Well, I was just going to say this reminds me of a woman I worked with. This was her thing, was she didn't want to see ever see Booleans in parameters. And I hadn't really thought much about it until she pointed out. It's oh yeah, that doesn't make sense. Let's use enums instead. And I was very proud because we were working in this absolutely huge code base, right? That had been years and years and years in the creation. And I found a function that had 5 Boolean parameters, 3 of which had default values. There was almost no way it was going to be called correctly, right? I mean, it just wasn't going to be. And I remember taking it to her it with great delight and said, "Hey, Beth, look at this one." But yeah, that was the learning for me. I realized, this is just crazy. And it makes so much sense, right? There's only 2 possible values. That means it's a bool, right? And no, that's not a good idea.
Although for Booleans, it's actually fairly easy just to come up with an enum and make it an enum class these days to replace that, and it's more descriptive, it's easy to write. That's great. For things like integers, where you've got different integers that mean different things, then you're probably going to have to reach for strong types. And we don't really have good support of the language for writing those. You have to write them out in a very longhand way, which is a shame. Mm-hmm. And I'm hoping that one day we will get language support, but It doesn't seem likely it's going to come soon. But there is a flip side, which is if you're going to take the effort to write a strong type for something like an integer in the first place, you can actually take it further and do things like specify the range more narrowly. So if your integer is only valid for values from 0 to 100, then enforce that in the constructor, whether that's with a contract or an assert or check and throwing an exception, depending on your need. Once you enforce that in the constructor, you know that is only ever going to be between 0 and 100. You never have to check it again. You get all these additional benefits. You can improve performance and certainly safety. So, yeah, if you're going to take that effort, then think about maybe going even a little bit further as well.
Yeah, I actually remember one more approach to this problem right now. So there is this nice article, I think it's by Google, and it's kind of scientific stuff about how to detect cases where the parameters are actually passed in the wrong orders based on the naming. So they kind of analyzes the names for the arguments for the parameters and can detect some cases when the parameters were actually passed in the wrong order by mistake. Like they kind of avoid the cases like when you do that on purpose, like swap or something, but then they can detect the cases. And we actually implemented this paper as a code inspection in C-Line, and it works. I mean, like in some cases when you have a proper naming, which not always true, of course, but like when you have a proper names for your arguments and parameters, it can sometimes detect and can be very useful in not in all, definitely, but in many cases. So that's interesting to know that there is actually even, a scientific paper on that. But strong types, yeah, I like the solution more.
Yeah, I know there's been proposals in the committee, but it's trickier than it sounds at first.
Yeah, that's true.
I actually quite like the way Swift does it, which you got from Objective-C with the labels, which are like named arguments, but they're actually part of the function name. So it describes what each argument actually does. It's almost impossible to get that wrong. Don't think we'll see that in C++. So.
Yeah, but that's Swift, yeah. But that's where we actually took the idea of the hints, like the type hints and the parameter hints. Like if you don't have this in the language, let's just add this in the editor so that we can actually show you and what to pass to the function or to the template.
Yeah,
so yeah,
definitely helps.
I worked on this was in Python. It was a Python code base, but the protocol was that you would put underlines, underscores in the function name, and the parameters were in that order. So in other words, you would basically say, I don't know, move underbar to underbar with underbar, and that so that meant that you fill in those parameters as you read it. And I don't think there wasn't anything language specific about that. It was just a protocol that particular company had developed, and it did help when you were looking at code you hadn't used before. You knew that worked.
Yeah, so you can read through it and kind of fill the gaps. Yeah, right. That's true.
If you replace those underbars with colons, then in Objective-C, you just actually slot the parameters in those places, and it's even better.
Exactly. Yep, it's exactly that. Yeah. Which may have been what inspired it. I don't know. It's possible that Python codebase was originally developed by someone who had done some Objective-C programming. I don't know.
Possible.
Yeah. Okay, yeah, and moving to the next topic. So for today, in terms of the news, so there's a nice article discussing is the return value moved to a copied? And I kind of like it because I'm always wrong with this thing. Like every time I look at the code, I always have the concerns about that, and especially in some tricky cases. And so that's kind of classical C++ question raised and discussed in different examples. And this article written by Philip Tretner, so he's discussing a few more or less basic general cases. And he has the examples of the move and the copies and the cases when the object is directly constructed in memory, which is actually the majority of the cases in the article. But the thing that I liked is that he's showing the assembly to analyze the call graph. So you can actually visually realize what's going on there. So you see when there is the constructor call, when there is the destructor call. So when there is this move or copy. So you can actually visually understand how it works. And to me, it works better because I kind of memorize visually, and so I can actually memorize the pattern for the specific code piece. So he's discussing like the direct constructing objects in memory provided by the caller functions. The thing which has a very interesting name, I would say, it's called unmaterialized value passing. I really like the name. I've heard it for the first time in the article. I think it looks great. All these cases with returning local variable and, this named return value optimization and returning a function parameter which behaves differently, moving from a local variable. So all these cases are kind of discussed there. And finally, in the end, there are a few cases which triggers copy. So I guess there are more cases for move and constructing in the memory than copy actually in the article, but some specific cases for copy, which shows that you have to treat references accurately, are there in the end. So yeah. And, going back to the code analysis from which we start, while reading through the whole article, my main thought was like, why the code analyzers are still not showing this to me? Because that's the typical issue I'm usually having. Like, is this a copy? Is this a move? Or what's going on there? And if some tool can just, show a small tip to me, I would be more than happy. So, that was my thought while reading through the article. And I really like the assembly parts there to understand how the things work. So I don't know what you think about it. Well done.
Well, it's something that I think all too often engineers don't know enough about this and understand what's really going on. I think RVO is this incredible mental breakthrough. When I began to understand what was really going on in the covers, it kind of changed how I thought about things. And for example, when we teach new programmers how to program in C++, they write a function and it returns an int. We say, hey, good job. And then they write a function and it returns a double. We say, good job. And then they write a function and it returns a vector. And we say, whoa, don't be returning vectors because that's expensive stuff, right? And in fact, no, it's going to RVO that. So now, of course, it would move it, but it's not going to move it. It's not going to move it. It's going to create it in place. And that's, I think, often overlooked. And we really need to make certain that engineers understand that's what's happening. It's an incredibly important optimization, and it is not how we teach people what's happening. We say when you say return something, it copies this somewhere else. Well, it can, but for the most part, it won't. It's going to create it in place, and that's a really important optimization, mandated now by the standard in many cases, and it changes how you think about things. It really does. And one of the reasons that's important is because there are times when people want to return something like a container, a vector, or something like that. And they say, well, in order to prevent a copy from happening, I'm going to wrap it in an std move, which turns out to be a pessimization because you're forcing then a move construction instead of just creating it in place. And this is a trap. And we need to do better training of engineers to understand what RVO and NRVO are when they are used and make it clear. And, I have in my training, I got some slides from Dave Abrahams, which I think are the best single set of slides I've ever seen. So I made a lightning talk out of it. So you can look at for the lightning talk, because they show what's going on in a way that really makes it not just explain what's happening, but make it so that you recognize that the compilers are going to do this. It's a no-brainer optimization for the compiler to do. And so it gives you confidence, because I had read about this optimization. I don't remember where, probably from Andre. But I'd read about the optimization. It was kind of like, can the compiler really do that? I didn't understand how it did it. I was just assured, the compiler will do this. And it's like, okay, maybe. When I saw Dave's slides, I realized, the compiler would be crazy to not do this. It's an obvious optimization that any compiler is going to do. And then it changed. As when I saw that changed how I thought about code a lot, because I began to realize what's going on when you do a return that I hadn't realized before. And it makes it really clear when you need to do an std move and when you don't. And of course, most of the time you don't. The only time you use an std move is if you have a parameter passed in that's a temporary and you want to pass that on through. And that doesn't happen often, When it happens, use std move. In almost no other situation would you ever do that. Or you could do std forward if you had a appropriate parameter coming in. But if it's a local, and even if it's a parameter that's a by value parameter, that's where we have this special classification of the x values, right? Where it's an expiring, technically it's an L value, but we treat it as an R value because it's an expiring L value. This is the case. This is this special case to basically say, if you have a parameter that is a value parameter and you're returning it, of course you want it moved. And so the compiler just does that. If you write in an std move, you aren't pessimizing things, but it's a waste. You don't need to do that. And you're in fact betraying that you don't understand how C++ works, which is a little embarrassing.
So you understand how C++ works.
Well,
yeah, that's what you need to understand, actually.
That's right.
We all have a little glimpse of how C++ works, right?
But it does tie back to something you were saying earlier, John, that it's best to start from writing your code to be clear and understandable before worrying about performance, because half the time you're actually making it clearer for the compiler as well about how it can reason about your code, and then it can do these optimizations for you because you're expressing your intent. And then the compiler says, yeah, I know a good way to do that. And that's why we really need to be using tools like Compiler Explorer or any sort of performance measuring tools to see, well, what's it actually doing? Is this really a problem? Is this something I actually need to get down and do something specific to handle rather than just expressing my intent? So I always prefer to raise that level of abstraction. And these language features are trying to do just that, to raise our level of abstraction more towards what we intend. So a moving story, definitely. Move semantics will come back in a moment, I think, actually, in the standards news as well. In fact, maybe we'll start with that one. So standards news. We have a few papers to look at this month. We'll start with P2445, stood forward like. Now, this is a paper I actually had a glimpse of last month before it was published. And I did a little write-up of it, and they realised, hang on, it's not published yet, so I'll save it for next month. So now's the time. And on the face of it, this seems like a rather odd facility. And why would you want it? A little bit arcane, but actually there's a very good reason for it. So stood forward like is like stood forward, in that stood forward takes the value category of something you pass to it, which may be generic, well, usually is if you're using it, and will preserve that value category as you pass it on. So if you give it an R value reference, it continues to be an R value reference. If you get an L value reference, it continues to be an L value reference, and so on. Either you already understand that now or you don't, in which case you can zone out for the rest of this. But stood forward like says, well, yeah, I want to preserve the value category, but not the thing that I'm passing it, but of something else, and apply it to this thing that I'm passing. So it's like forward this as if it's this other thing, that value category. Now, why would you want to do that? That sounds like a really weird thing to want. But there's a few cases, actually, but the motivating case is something we talked about last month. That was deducing this, where we can now specify an explicit argument to a member function as being the this argument. And we can make that generic, which means we can capture it by different value categories. So it could be an R value reference, or it could be a value, or it could be a reference or a pointer. It could be any of those things. We won't necessarily know in generic code, but we may also want to refer to a member of that object, and then forward that on, combining the value category of the member itself and the object it's being called on. And you can do that with stood forward like. You say forward this like the object it's a member of. That's the motivating case. If you think it through, that makes a lot more sense. Apparently there are some other use cases as well that drop out of it. I have to read the paper for that. But one of those sort of little things that you think, yeah, I can see why we need that. And then you forget all about it. Most people will probably never need it, but it's a useful one to have been proposed anyway. don't suppose you have any thoughts on that, either of you?
Yeah, it looks like a good fix, which we need for deducing this. So at least the main use case sounds like that. Yeah. So while reading for the intro to the proposal, I haven't read it in full, just the first part. So it looks like, yeah, that's indeed the thing we need for the deducing this. So I'm wondering if there are more, another inspiring cases where we might need that. So I'm not sure if there are any in the proposal itself. So, but for deducing this, I totally agree that we might need. But the name at least sounds a little bit weird to me. Like, makes sense when you have this explanation what it actually does, but like, yeah, a little bit creepy, mimicking something. Yeah,
there is a part of the paper which I would need to read through a few times, I think, to get my head around it. So I'm not going to do it justice, but it's basically pointing out that we already have. Right now, if you are dealing with a member of an object, then the way you deal with that object is a combination of the value categories of two things. And then there are language rules that automatically apply to give you a combined value category, if you like. And in some cases, they don't quite do what you would want. And so there's like different models you can use. And I think stood forward will actually give you control over which of those models is actually applied. So even with what we have today, you can get more fine-grained control about how value categories emerged. And let's say it gets a little bit off into the weeds. Sure, it's really useful in certain particularly library implementation scenarios, but maybe less applicable to an average application developer, I think.
This is the kind of thing that brings out my skepticism that says, does this need to be in the standard? And maybe I'm missing it. Maybe particularly when we start to deduce this and we start to use that more, then it's going to be obvious why we need to have this in standard. But if it can be done, then I'm wondering why you couldn't just wrap this yourself and use it in those few cases. Because putting it in the standard and explaining it to everyone, there's some overhead associated with it. But maybe I'm making the bar too high to put in the standard, but lots and lots of things go in the standard, and I kind of wonder if the bar shouldn't be a little bit higher. But I'm not. As I said, it just raises my skepticism here. It's not that I definitely think this is wrong to put it in the standard, because it may be that when you try to implement it, it's pretty tricky to implement, and you really want that to be done by the compiler instead of by a library that you've rolled yourself. That could be. But again, I'm wondering, is this going to be used often enough that it should be in the standard?
So I think both those are actually addressed in the paper. It's a reasonable concern. And if I remember right, it does say, yeah, you could just roll this yourself. But it is sufficiently tricky to get it right. You have to think about all these different combinations of value categories, and thinking that all through is non-trivial. It's not necessarily the implementation that's hard, it's the getting the right semantics. So we really want to just do that thinking once and have a standard facility that does the right thing. That was my reading of it anyway. And in terms of when you would actually use it...
So it should be in Boost. It should be in Boost for a year or two, and then we put it in standard.
Maybe. And I should have prefaced all of this by saying that these are papers that are in flight. They're not currently adopted into the working draft. So we may not get this, at least not yet. The other side to it, how often we'd need this? A lot more when we get deducing this, which has been adopted.
Absolutely. I understand. Yes.
So let's say that is the motivating case. So we'll see how the discussion goes, but it's an interesting one anyway. So, talking of interesting papers, P2461 is another one that I alluded to last month before it was published, and now I can say a little bit more about it. So, this is the new proposed syntax for contracts. So, obviously, we don't have contracts yet either, but during a discussion of, I forget the paper number now, the current minimum viable product for contracts, some concerns were raised over syntax and how it interoperates with other things, and a few things like, are we going to lock ourselves into whether we can refer to a parameter in a post condition using its initial value, and lots of questions about that, which we want to defer, but we don't want to lock out the design space with a particular syntax right now. So in the middle of all this proposal came up to say, well, what about if we have a different syntax that looks more like lambdas? And initially it was just the captures list from lambdas, and it seems to have evolved a bit now to be more fully like lambdas. So rather than the double square brackets syntax that everyone says, yes, it looks like attributes, but it's not, which is one of the problems. We have something that looks like lambdas, but it's sort of not. But actually, when you see it, it makes a lot of sense. So forget the closures for a moment, just the having what looks like a function body, and you've got code in there that gets executed, and you imagine that's a lambda. So now you've got this deferred execution model that we understand. We say, right, here's some code. It may or may not run, depending on compiler flags or how it's implemented. So we can't reason in advance about that sort of thing. We know how that works. We have post conditions can take an optional argument, which is the return value. So that just comes in as if it's like a function argument to the lambda. And then the the capture list can be used particularly on the post condition, and it's explicitly not proposed yet. It's saying this is what we could do because we want to defer that, to say how you want to capture a parameter to be used in a post condition. Do we want to capture it by value, in which case it's got to be copied, in which case we automatically understand, well, this has to be a copyable value. So if it's a move-only type, you're not going to be able to use it like that. Or do you want to capture it by reference? In which case, well, it's obviously then going to be the value at the end of the function. So if it's mutated in the meantime, it's the final value. But now it's explicit in the code, in a syntax that we're already familiar with, how that works. So I think this has a lot of potential. It solves some other problems as well, like it's not an attribute issue. Potentially some interplay with C, because they want to get their own contracts, and they don't necessarily want to use the attribute syntax, and there may be some problems there. I just like the way this looks as well, and it opens up lots of additional things that sort of drop out of it. That for me is often a good sign that we're going the right way, when it doesn't just solve this problem and this problem only, but opens up lots of other solutions at the same time. So do you have any thoughts on that at all?
Yeah, I kind of like the new syntax. I mean, like, it's definitely quite nicely readable. So, and I like that it looks like lambdas, The only fruit I have here, which is kind of the major thing, is that usually we have several revisions for the proposal, and with contracts, it looks to me like we're having more and more proposals around that. And so we're changing lots of things, and we're still discussing like the new syntax, whatever. So it doesn't look to me that we're going to end with something usable in 23. And it's a little bit sad. So I like the feature. I like the general, how it goes, how it evolves. And I really like the new syntax, I have to say. So, but the thing that we're creating more and more proposals around the topic, and they are kind of looks to me like, okay, let's start from scratch. We'll redo this part, and let's start from scratch. We'll redo this approach. I wonder where it kind of, end up in something usable for the C++ developers in the end of the day.
So one of the things that this does address, and you kind of alluded to this, Phil, is when doing a post condition, if you want to express your post condition in terms of one of your parameter values, which is a really common thing to do. So, for example, I'm calling some function, and let's say I pass in a couple of, among other parameters, there's a couple of values that specify this is the maximum possible value and this is the minimum possible value of what I'm looking for. So I'm looking for some value that'll be between those two. Obviously, your post condition is going to be that the return value is greater than this minimum and less than this maximum. You have to do that. But if the if the function were to modify either of those values, that's worthless. You don't really want to express the post condition in terms of what is the final value of this parameter. You want it the incoming value. But the problem with that is there was no way for the original proposal to deal with that, because the only way you could do that in practice was to make a copy of the parameters that came in. But you can pass a parameter that's not copyable. So what do? You see what I'm saying? That's the problem that the original proposal had. And so they wimped out and they said, when you are expressing a post condition, you're with a parameter value, it's the final value of that parameter, however it changes within the use of the function, which is exactly the convenient and easy to do thing, and it's always possible to do because that's the value you have at the end of the function. But it's useless. That's not the value you want. It's any post condition that is, unless the parameter is passed in as const, any post condition expressed on a parameter value is it's meaningless, because the whole point of a post condition is it should be regardless of how you implement the function. And so if in the implementation of the function you change one of the parameter values, you don't want to express the post condition in that. But they couldn't, because of the fact that some parameters could be passed in that can't be copied. Then what do you do? And this allows us to express this, and essentially says, if you're not going to be able to express it. If you have a parameter you're passing in and it can't be copied, then you're not going to be able to capture it by copy. And so it sidesteps the problem, because it's going to be rare. How often do you actually pass a parameter that can't be copied and you want it? It's not going to happen very often. But that's what the original proposal was stuck with. There was no way to work around this because of this possibility. And now with this syntax, we can say, oh, if you have this situation, you just can't have this situation. You can't express a post condition in terms of a value that you're passing in that can't be copied, unless you make it const, in which case then you could do that. But for no other reason, I like that, and I think it basically falls into what you're saying, Phil, which is it's solving multiple problems. It's clearly a direction to move in, because that was a really annoying problem. I don't know if it was a crippling problem, but it had forced the original proposal to make the wrong decision about what to do with post condition values of parameters. Now that can be addressed.
Yeah, I'm thinking actually now, we nearly got contracts in 20. So we stopped them at the very last moment. And now with all these things being discussed, I'm just wondering how much of an error we might have if we actually have the contracts in 20, because we stopped them quite late to what everyone heard about it. So we nearly got them, but then we stopped. And now we start digging into them more and more, finding all these cases and adding these, new proposals. And I'm just wondering what's there behind the curtain. Do we have more that we haven't heard about before? So maybe that was indeed the right decision to stop it then. So, because of all these details.
And I can say that, and I can't quote anyone because this is really based on things that I've heard behind the scenes. There is a feeling amongst those that no, we're not going to get contracts in 23. It is now too late given what we're dealing with here. Which is not to say it's impossible. So that's just people's feelings, but it's unlikely at this point. So there's a good chance for 26, though.
Well, one of the problems with contracts is people had fundamental different ideas about what they were trying to do with it. It wasn't just, with Lambda expressions, there was lots of discussions about what the syntax, but everybody understood, no, we're trying to create an object that you can call. That's, trying to create a closure somehow. But with contracts, is this entirely for testing, or are we doing something that, having created the test, we can allow the compiler to use the assumptions in the contract to optimize the code? And that was a very contentious way of looking at what is it we're trying to do here? And I think that discussion needs to be taken into account rather than just Rather than just focusing on what the syntax is what is it we're trying to accomplish? And that's a deep question.
Yeah, so one thing we didn't really discuss this time, because we talked about it before, is that this new syntax paper is based on the current, what we're calling the minimum viable product paper, which is the really stripped down contract. So just the bits that supposedly everyone agrees on. It turns out there are still some disagreements, but we've got it down to like this minimal set. Right, what's the minimal we can get in? And then we can have those arguments about assumptions and modes and things later.
Mm-hmm. Mm-hmm.
So we're actually still deferring that, and we're still missing 23 by the looks of it. But maybe that means that when we get it, we'll get everything. But I think it's still going to go in piecemeal. We're going to get the minimum stuff, and then we're going to build on that. What I like about this new syntax paper is it gives us a very clear direction on at least some of those things that we're still deferring to the future, even if we're not going to commit to them just yet. So I think it's a positive step, even if it's going to push it back. Talking of positive steps, what do you think about making the standard library into a single module? So that's P2465, standard library modules std and std.Cpp.Chat. So this is where you can import the whole of the standard library just by doing import std, but not including the things that are in the global namespace for C compatibility reasons. If you want those, then you import std.Cpp.Chat, you get those as well. But at first it seems like, well, I really would rather a more fine-grained approach, but there's good reasons why they're not presenting that. But before we get into that, any comments on this in general?
Well, no, that's the trade-off. How convenient is it to just say, yeah, I want to use a standard library. Why wouldn't you? But on the other hand, yeah, maybe I do want something a little more fine-grained because maybe I'm doing a freestanding or something like that, and I don't really need all this stuff because I can't use it anyway because it's freestanding. Yeah,
freestanding is an interesting angle, I think. But, sorry, Anastasia.
No, that's fine. I'm just thinking that like granularity is good, but unless I can actually use the thing, I don't know what I need. I mean, like I can't use them still properly except for just a few cases. So it's hard to say what I actually need from the standard library and how the granularity should go. So maybe that's a good decision for now, just to go with like nearly all or nothing, and then think about some further steps. I don't know if that's scalable. That's a good approach, probably.
So it turns out, and I got this mostly from Bryce's discussion in the recent CPP cast. If you haven't heard that episode, that's definitely worth listening. He goes into some of this in quite some depth. That they actually compared using more fine-grained modules with just a single module, and the single module performed better. So it's the opposite of what we would expect with the hash include model, where you actually do it more fine-grained for performance reasons, but compile time performance reasons. But including a single module was actually faster to do, at least with current tools. So that's certainly not a reason not to do it. The other side is you can get into a situation with fine-grained headers being included where you don't get a complete overload set. And so when you do have to bring in another header, it actually changes the set of available overloads and can introduce problems after the fact, which is not a situation you want to get into. I mean, it's a general C++ problem, but it exists with the standard library today, which you don't get if you import the whole standard library.
That would be easy. That'd be easy to track down, Phil. That's not going to take you days and days of figuring out what went wrong because you thought it used to work right and now it doesn't work right, and the only thing you did was include this other header. That couldn't possibly happen.
No, well, not for you, John, because you understand C++ perfectly. No, I don't know how often that problem happens with the standard library in general, but it's a real problem that you can have something working with one include something else, and then the first thing stops working. And including the whole of the standard library in one go just solves that. So they're the two things I got from this anyway. It seems like I think it's a positive direction embracing the modules world. We'll get there one day.
I hope so.
This was always something that scared me a little bit about what the standard said about including headers, that the standard didn't necessarily say which headers included other headers. So you could end up in a situation where on your system, you include this header and everything builds, but you take this exact code and you take it to another compliant system and it won't build now because one of the headers that you are including was including another header, which is on this system doesn't get included. And so something doesn't, that always scared me. Now I was told when I talked to implementers, they said, it turns out that usually headers don't include other headers. Whatever's common, how do I say this? They would not include other top level headers, but they might have some common thing so there's another header that we don't, that's not published, so it's included by both internally or something like that. So these things tend not to be a problem, but that's not a very strong assurance. This, on the other hand, is a much way of, what's that?
It's not been my experience. I get bitten by that a lot.
Okay. But this is going to make it so, yeah, I just want to turn on the standard. Of course, now the question is, when would you not want that? Why not just assume everything imports the standard?
Freestanding. You said so yourself.
Yeah, I suppose. Yeah.
Yeah, I don't know if there's any proposal for like a std.freestanding module. Maybe that would be an actual evolution, but there may be some reason why not as well. I don't know.
Like, I'm pretty much sure that we'll get some when the people actually start migrating the code bases to models. I mean, not playing with the, some samples and some compiler pre-implementation, but when they actually start migrating the real code bases, we'll get like tons of these things, I guess, in discussions.
Well, right now we have two problems. One is modules are new, so there's very little tooling support. That's gradually coming, but until that's widespread, people are not going to embrace it. And the other is the standard itself is not using modules. So this is promising because if the standard itself starts being packaged as a module, people are going to start using that as soon as they can, and then they'll say, right, now I want to modularize all my stuff as well. So I think that's going to be a necessary first step for a lot of people.
Yeah, I would agree. Like, if the standard doesn't use that, why would I?
Exactly, yeah.
And it may be that we have to rethink things because, as I said, this kind of assumption that we made that, well, importing everything is going to be more expensive than just importing the stuff you need. Well, if that's not true, then maybe we need to rethink how we think about these. I mean, right now we all have a mental model based on pound include because we've used that for, ever. And if that's not the right way to think about it, then that's going to take some getting used to, some rethinking things.
Yeah. Okay, well, we seem to have gone a bit long on that. We actually wanted to reserve a bit of time to talk about something close to all three of our hearts, I think, which is conferences, particularly as we just had CppCon we've all been involved with. Were you at CppCon, John?
I was there for part of, all of it. Yes, I was there.
What was special about this year?
Well, this year is the first year we did a hybrid version. We've done, of course, on-site for 6 years, and then last year we did online, and this year we've done hybrid. That was a bigger change than I thought it would be. It was kind of like, how difficult can this be? We've done on-site, we've done online. Hybrid can't be that hard. And I will say we completely planned the program schedule about 2.5 times because the first time wasn't quite pleased with it, so we did it again, and then it was working, and then we redid it again, and it's way hard. But I really am pleased with where we ended up. I was still. I went into the conference with a lot of trepidation. I was afraid that because there were a lot of things that we that have become part of CppCon that we just couldn't do this year. We didn't have tool time. We didn't have author signings. There's just a lot of things that we normally do. Poster program, lots of things that we just couldn't do. And so I was afraid it would feel like it wasn't quite right somehow. And in fact, it was wonderful. It was so much better. Maybe I had low expectations and set a low bar, but it was amazing, particularly the first day when everybody who you saw said, "I can't believe I'm here." And it was just terrific. So there's tons of excitement, tons of positive feelings. A lot of people are delightful and optimistic to be able to get together and see each other in person. I'm so missed you guys because I didn't get to see either of you there. But the people we saw, it was just terrific. It's just so exciting, so much energy, so much positivity. That it didn't, and people would sometimes ask me about, well, what about this? Well, we couldn't do it this year. Oh, okay. Disappointing, but not going to cry about it. It was what it was. A lot of fun, a lot of, as I said, everybody was happy. Everybody was excited. Everybody was positive. And so that's been great. That's been really great.
I was definitely disappointed to not be there in person, but I was there in spirit and virtually, of course, as was Anastasia.
Yeah.
But I did manage to get to NDC Tech Town the week before. So I got to Norway in person. So I had a bit of a taste of that as well. And I can agree that even like a scaled back event, it just makes such a difference to what we've been used to for the last nearly 2 years now. That, anything is just amazing.
So what kind of attendance did they have on site? Were they hybrid?
Nope, they were meant to be fully in person. One of the keynotes was meant to have been given by Jason Turner. He couldn't arrive, but he didn't really know that until fairly late, just because of the way the rules have been changing. So they brought him in virtually. So he came up on a big screen. But that was about the only one, I think. There might have been one other. I'm not too sure, but it was primarily fully in person, that they were a bit more bold. In Norway, they had a little bit more of an opportunity to cater to the local crowd.
How is the attendance compared to say 2 years ago or the last time they did it?
It was a little bit down, but not that much. Definitely more than half. I'd say maybe 2/3. Difficult for me to remember the numbers, but I think it's quite good, quite strong. I say because most of the attendees were fairly local, not just to Norway in general, but to that particular region of Norway. So it was fairly easy for most of them to get there. So that was a bit of a difference.
Yeah, I guess Core C++ in August was also kind of local in-person, mostly event, so in Israel. And they have quite a big event compared to their, I guess it was the first one just before the pandemic year. And I've heard that it was kind of comparable. It was fully local, mostly with the exception to just a few speakers from abroad, but it was quite big and they had great time there. So, yeah, well, I feel actually envy to all of you.
Yeah, sorry. Well, that was one of the things. They made that as a conscious decision. In other words, they were happy the first time, of course, to have international speakers and international attendees. But this last time, they really made it a conscious decision to kind of say, well, we really only want locals and planned around that. Yeah. And so I did get a chance to, fortunately, Inval was actually who was an organizer for CppCon, CPP Core, was able to attend CppCons, and I got to talk to her a bit about it. And she brought me a gift, a very sweet gift. It was Jerusalem honey, a little jar of Jerusalem honey. It was great. Or will be great. Still sealed at this point. Anyway, yeah. So that was what they were doing. We, of course, we knew going in that it was going to be, we weren't going to have almost anyone from Europe, Timor accepted.
Yeah, Timo had a very tricky trip because to get Timo, and if you don't know, Timo is back to JetBrains as our developer advocate. So yeah, a little bit stepping in the shoes of Phil. But to get him to CppCon, we had actually asked him to come to St. Petersburg to spend his first 2 weeks with us here in St. Petersburg. He actually visited the office. He was quite happy to see the team back. But yeah, after that, he could actually fly to United States to CppCon. So yeah,
right.
And he actually preparing right now a trip report about the CppCon this year. And I've already seen the draft. He's very much excited about the event. And so he's very happy about how it all went. And he's even happy with the fact that there were not so many people actually there exactly in the venue, offsite, because he got a chance to talk to the majority of the people attending the CppCon, which is totally impossible if you have 1,500 people there. So that's just that's mind blowing.
Yeah, it had kind of more of a C++ now feel to it. Not entirely, but the smaller attendance, a lot of people did, in fact, comment on that. It felt different because you had better access to speakers. Because of the ratios, and I think it was a positive experience for that reason. And of course, C++ now we are planning. We're going to do it on site. Better, the world better straighten itself out by May.
Yeah,
we can do that. As far as international, we did have people from Canada and people from Israel, but no one from Europe, and that was noticeably felt.
Except Timo.
We missed you. Except Timo. We actually did have more attendees. We set a record for total attendees. Not a lot more. I think in 2019 we had 1,400 on site, and this year between on site and online we had about 1,450. So we did have more. But we did have a lot of people people who were there, who were basically expressing a kind of fatigue of virtual events. It's not nearly the same kind of thing. It's more tiring, and it's a different experience to be there.
Yeah, it's definitely different. Yeah, that's true. I mean, even this year, because I was visiting CppCon only just online, but last year it was much better for me in terms that I managed somehow to allocate, a whole week in my work timetable to be the part of CppCon. This year, unfortunately, the only talk I visited live was actually mine. The rest of them I was mostly just listening afterwards. So the same day or maybe the day after the day. So, and I guess none of them were live. And that was sad thing. So I would prefer to be part of the whole inspiration, not just, listening to the content later. But yeah, there are these downsides. But I actually wanted to ask you, John, what was this story about the figures and the signatures with the speakers' figures? I enjoyed it. Every time the keynote started, you were bringing this figure to the speaker and asking to sign. So I would just wanted to ask what was the story behind how it all went, because it looked very interesting from the online perspective.
So we made 4 bobbleheads. Well, I shouldn't say we made 4. We actually, I guess there's several hundred of them got made, but they're 4 different models. So yes, when Bjarne did his talk, I presented him with his bobblehead, and I gave him a pen, and I said, "You're going to be signing them," because of course we were selling them in the store. So the models for them were Bjarne and Herb Sutter and Sean Parent and Scott Myers, who of course was not a keynote this year. He hasn't been active in our community. I'm going to see if I can get him to come next year and do another training. After he retired, he did come to CppCon one year and did a training class on how to do technical presentations, which is something, of course, he does very, very well. So maybe we can get him to come back. Not making any promises, but we had those 4 bobbleheads were available for sale. We sold them as a set until the middle of the week or something like that, and then we started to let people buy them as individuals. So that's what the signing was for, because people could get their sets autographed. So that's what it's for. It was really exciting. The bobbleheads are kind of cute, and I wrote this thing about how you can use them to solve technical problems, which is a surprise to some people. But no, you can use them to solve technical problems, which of course makes them tax deductible. But the idea is that you explain your problem in simple terms, very clear, break down all the steps, because you see, unlike the originals that they're modeled on, the bobbleheads don't have much computing power and they don't have much memory. So you have to explain everything at a very, very low level. And of course, when you do that, you very often will discover your solution to the problem. And so that makes them an important technical tool. So we did a vote and asked people who they would like to see the next bobblehead made. Unfortunately, that will probably be a while, because we have so many of the originals that we still need to sell. But eventually, we will announce who the next bobblehead is.
You probably can send these figures, to the user groups worldwide. I don't know, just generating ideas.
One of the things that we had discussed doing was to allow online people to purchase things, and we would just ship them out to them. But there was a few logistical things that made that tricky and hard to do. But that was one of the things we wanted to do, was be able to send shirts and bobbleheads and all the other stuff that we sell with the CppCon and or ISO Standards Foundation logo on them. And in fact, we did. Let's see if I have an example here. We made buttons, including Cpp.Chat buttons. So I brought some of these back with me. But anyway,
cool. Yeah, that looks cool.
Fact, yeah, it was.
We actually have, at C++ Russia, we have ducks. And we are just printing these ducks for all the attendees, I guess, at least for all the speakers, and maybe the attendees can buy it as well. I don't know, because I usually get this duck as a member of the program committee. And definitely, like, my children are just grabbing all these ducks from me, but they are actually cool. But they're coming every year asking, like, if we're gonna get a new duck from your conference, so maybe the tickets could also be popular. I would explain to them who is Bjarne.
Well, actually, so Incredibuild made a little Bjarne doll that they raffled off. And so I guess they had presented that to him when he was in, I guess he was the keynote speaker for C++, but he didn't attend in person. So they presented it to him at CppCon.
Okay, cool. Yeah.
My dog ate my C++ Russia duck just this week. So I need to get another one.
You probably will get another one because you're a speaker for this year. So yeah, we'll have an online pure virtual event. Unfortunately, we can't handle like any kind of a hybrid or something, at least for now. So we'll have an online event in a couple of weeks, just 2 weeks, I guess, before this starts. So it's from 15 of November. So yeah, Phil is one of the speakers. Actually, we have quite a big intersection with the CppCon this year. So we have Phil, we have Titus with the same talk. I guess we have Andreas Fertig and Anthony Williams, who were probably also giving the talks at CppCon. So yeah, we have kind of some talks from the CppCon repeating here. But overall, the aspect of the conference is a little bit different. So I was looking at the program we just finalized. This was Russia one a couple of weeks ago. And I was looking at the CppCon program, and they looked, I would say, differently to me. And that's a good thing, probably, that we have different aspects. So yeah, but Phil, you'll get the duck, and you won.
Looking forward to that.
Yeah.
This time of the year is always pretty dense with events in our community, but I think this year even more than usual, maybe just because CppCon is a bit later. I think NDC Tech Town was also a bit later. So we had Tech Town,
Yeah.
CppCon, next week meeting C++, the week after C++ Russia. I think ADC is on at the same time as C++ Russia. And then beginning of December, we've got CPPP, which I'm also going to be speaking at. I just found out this week. And I think C++ Summit as well is usually at the beginning of December. So I think there's even maybe 1 or 2 weeks that doesn't have anything on. So
CPPP is Paris?
Usually. Well, say usually. It's been in Paris once.
I guess it's online.
It's going to be fully online again this year. Yeah.
Yeah.
Okay. And ADC is going to be in London, and they are doing it.
That's going to be hybrid. Yeah.
Yeah. Yeah. So that's going to be great to see that. Great to see the face-to-faces, because I can tell you, having been through it and having observed everybody who was there, I don't know what to say. I assume that people in the audience, if you haven't been to a face-to-face yet, you're looking forward to it, and I'm going to tell you that it will be as good as you think it will. It'll be great.
ADC is the Audio Developers Conference, so obviously it's going to be primarily appeal to people that are in that field. But if you have any interest in audio and music at all, and C++ or programming in general, it's definitely worth going. If only for the lightning talk. So they call it the open mic night, which is never recorded. So you'll get some things in there that wouldn't necessarily want to be recorded. But there's also some just amazing musicians who just get up and just play something, but often using hardware that's not been released, or some software they just hack together, or it's just next level stuff, I think. So if you could ever get a chance to go to see that, you should.
It makes perfect sense, but it hadn't occurred to me. It was Timur who explained to me that most audio engineers are also musicians as well. I mean, it's not it's not a requirement, of course, but it turns out that the whole conference has lots and lots of musicianship and of course the open mic night. That's why they don't call it Lightning Talks. It's open mic night, because people are showing off cool stuff that they're doing in conjunction with their software.
Yeah, AD is actually, I have a very good memories of it. I think I've been to it several times, maybe quite many, I guess. And this open mic is just a thing. So it's really very great and inspiring. And you feel the vibes, because all these people are talking about amazing stuff. So even if you're not a musician or just getting into this kind of like a developer, it's still very, very much inspiring. And the expo was always very much inspiring, because they have all these kind of cool devices there, which you can actually touch, because with the software, you usually can't actually touch the software. But here you have all these hardware, all these cool devices, and you can play with them. Do all this kind of stupid stuff, like pretending you're good at that. But yeah, I really enjoyed that. That was good times. Missing that as well.
We need to get Herb along to an ADC sometime, so he can play piano.
By the way, was he playing this year?
He actually played with the band.
Cool. Was that recorded?
Yeah, he sat in them with them. Well, it was recorded, but I'm not sure it's going to be released. And that was just part of the run up to the. We have the band play before and after the plenary, each plenary every day, and so they start like half an hour before, and so we don't.
You probably have to cut it as a separate video, and place to the channel as a separate video.
Well, there was. I know that at one point the band was simply out in the corridor, just busking. And I know Dave Abrams sat in. He had his guitar and sat in and was playing with him too. There's an awful lot of people in the C++ programming community that are somewhat musical, and I have wondered if we have a professional band there. Can we have some kind of event where I don't know, a lightning talk that's musical based or something like that? I don't know. trying to figure out how to make that work. Not being musical myself, I don't know what would work and what wouldn't. So I need somebody else to think about what would be a cool event to do. I talked to Dave about it, and maybe he'll come up with an interesting idea.
But that's the thing I usually. Yeah, that's the thing. Actually, I usually talk to people about the CppCon when they ask me about what the conference is about. I usually say that's the conference when they talk about C++ and play piano. So.
Yeah, playing in the key of C++.
That's right.
Yeah.
That's right.
Yeah.
Well, we have run really long. I'm sure we could talk for another hour or so just about this, but we really need to wrap up, I think. Well, yeah. But we'll see how we run it. But maybe we will do this again one time. But I said it'd be a one-off, but we'll see how it's received, I think. But let's say goodbye for now. So see you next time. Bye.
Yeah.
Goodbye, everyone.
And safe coding, of course.
Safe coding.